Welcome, everybody, to 26.1 AI Podcast. Today's guest is Divya Nagaraj, a current student at Stanford and also currently an intern at Facebook during COVID-19. Welcome, Divya.
Thank you so much. It's a pleasure to be here.
Wonderful that Ruth, our friend, connected us, and thank you so much for joining. Our first Stanford student, so exciting.
So how is it for you, Divya, biking around Stanford, building the muscles up?
Oh, it's absolutely stunning. Probably one of the most beautiful places on earth, and really wishing I was there right now.
And it sounds like you're down in Texas now,
Yes,
and doing work down there,
I'm quarantining at home with my family in Houston.
working during COVID. This is the new reality, right? And so what is
Yeah.
it? What does the day of the life of a intern at Facebook look like?
Yeah, so remote work is definitely becoming the new norm. It's a lot of coding, as you can imagine, a couple of meetings, mostly in the afternoon to late evening, because my team works on Pacific time. But it's largely very individualized. And yeah, it's been a great opportunity so far to just learn and be able to work and contribute to such a great company.
When did you first get the notice from Facebook that they were going to make alterations to this upcoming internship class?
Yeah, it was actually a steady stream of emails. So, in about early March, Stanford told us all to pack up and go home. Then, I'd say 2 to 3 weeks after, Facebook said most likely at least the first part of the internship will be virtual. And then I think probably sometime in April, they let us know that the internship would be all remote.
And I'm supposing a lot of your interaction is all done through Facebook tools. There's no Slack going on.
No, there isn't.
Yeah. I've noticed with my friends who work at Facebook, even long after they're gone, the best way to reach them is by Messenger.
Yeah.
So how does your team interact with kind of the data science ecosystem or the AI ecosystem at Facebook?
Yeah, absolutely. So broadly, my team is under the assistant team. So we do a lot of platform and runtime work for the people that are building language models for
So
these
is that similar to something like Alexa in the Amazon world or Google Home, or was that something of that nature? Explain to me a little bit, and probably some of our audience, our naive folks, what is it? What is Assistant?
Yeah, so it's pretty similar to voice assistants of other companies. If you have a portal by Facebook, you're able to communicate with it, and the voice assistant is what's housed on it.
In terms of priorities at Facebook, where's Voice Assistant at? Since, for example, like Apple and Google have won the phone interface, and Amazon and Microsoft, they're gone. They're never going to get into that. Is voice considered a really important interaction
Yeah,
channel
absolutely.
for its
So I'm
users?
not sure how much I can say until their strategy becomes more public, but they're definitely putting a lot of great minds to work on these problems. So a lot of really cool advances are coming out of the team.
So let's talk a bit about the transition from academia, to your undergraduate studies to internship. Do you yet get to use the natural language processing models that you learned in school, the BERTs and stuff like that, or is it just a completely different world?
Yeah, I'd say doing an internship is completely different than a lot of the research or classes I've taken. And I think probably the more exciting stuff for listeners would actually be in the research and academia portion. I don't know like how much I can say about what Facebook is doing, and I don't want to go anywhere super close to that line if that's okay.
Yeah, no problem. And maybe just philosophically too, do you think that these assistants, like I complain about Alexa all the time, it never has the answers to the things. I mean, if I want to set a timer, great, it does it perfectly. But if I want to ask a meaningful question, forget it. If I want to ask for a joke, yes, I can get, Jimmy Fallon on there very easily. it just seems to miss the mark to me still.
Yeah.
What is your feelings on kind of assistants, digital assistants, and things like that today?
Yeah, absolutely. I think that NLP technologies have made huge leaps in the past years in being able to understand and synthesize their own text, but there's still a long way that they have to go before they're able to be more conversational and be able to make these jokes or quips with people. Specifically, a lot of my work is within clinical NLP, so the more medical applications of it, and that's even more in its infancy, I would say. So it just shows that there's a lot of exciting promise for research in these areas in the years to come.
Does it show that there's promising research that'll have, early returns on that, or are these big pie in the sky type efforts? How close are we to getting to true conversational language
Yeah,
AI?
I think they're definitely on the horizon. There are a lot of emerging use cases right now that are trying to act as the bridge between the mainstay use cases and these conversational assistants or things that are a lot more on the horizon. So I think it might be a while before we see anything that's capable of conversing like a human, but the emerging use cases that will likely have an immediate impact in the next 5 years are probably the more exciting field.
Your focus is NLP, but you've also done studies on radiology. And was that a NLP approach to that? How did
Yeah,
you go about
absolutely.
the
So the
radiology?
lab I do research in is a data fusion lab. So specifically, it focuses on multimodal, multi-scale data fusion, where you're able to integrate information from a variety of sources. So things like radiology or pathology reports, as well as imaging, MRI, ultrasound, etc., as well as cellular and omics data. And then together, we're trying to throw all that data together and build some really interesting models off of that in order to improve like prognosis and diagnoses. Our lab specifically focuses on oncology, and our ultimate goal is to be able to catch cancers earlier through these kinds of techniques. So, in order to be able to build these really complex models with a variety of data sources, you need to first really understand each of the individual data sources and then try to find ways to put them together. And that's really where this idea of data fusion comes in. There are also a lot of considerations we look at. I don't know how technical you'd want this to be, but feel free to cut this out if I'm going too much into the weeds. But we are considering like different types of data fusion approaches. Typically, there are three main approaches. So one is like early data fusion, where you try to fuse all this data together and then build some kind of ML and analysis after that. Specifically in the clinical realm, that can be a little bit problematic because if you have a lot of omics data and just a little bit of clinical data, then the imbalance between the data sources can often overshadow things like clinical data, even though they're extremely important and it's a physician writing like a summary about a patient, things like that. So recent approaches have focused more on intermediate and late data fusion, where you try to do some different learning tasks for each data set and then integrate the predictions at the end via some kind of majority vote or some additional machine learning or deep learning to train each of the weights. Typically, late data fusion tends to be um, what's preferred and like the baseline to beat in a way because you're really like looking and studying each data set separately, and then you can weight like each model independently, so you ensure that um, every scale or every modality is providing some additional information for your model. So actually, the really exciting part about data fusion is figuring out like what models to use or what types of data and strategies to use. So typically, it tends to be a combination of some open source and models that we build on our own. Like typically, we tend to use CNNs for imaging data. We start with BERT, BioBERT, or T5 or something like that for clinical notes. We probably would try to do some kind of deep learning with omics data, so things like that, and then we try to figure out what models and combinations of models produce the best results. So it's a lot of trial and error and just trying to match against baseline comparisons.
And when you're running these trials, do you use things like Kubeflow? Would you use any pipelining to manage that process?
Yes, absolutely. So, specifically in NLP, pipelining is extremely important. Um, the pipelines I probably have built and worked the most with have been with regards to summarization. So, we have been trying to enhance information extraction from clinical progress notes and feed those summaries into potential classifiers or some like named entity recognition systems to pull out some keywords that we can then use classifiers on. So it's really about combining different technologies or different models or data sources to try to build some kind of predictions.
And Divya, in the lab, when you're working on these models, what's the emphasis? Is it on absolute accuracy, or is there any thought given to if you were to go to production, how feasible
Yeah, absolutely. So
these models are?
specifically with regards to NLP, accuracy is not very clearly defined. Typically, the baseline accuracy scores, like the blue and rouge scores, tend to be against a human generated summary, which, as you know, if you ask five different clinicians or people to write a summary about a particular text, their summaries are probably going to vary, which would then change the accuracy scores. So it's difficult to assess the accuracy of a particular summarizer, things like that. So at this point, I think it's still really early in its research and trying to figure out the best approaches and how we should determine accuracy even. And I think we're a little bit away from production.
Now, is there a human in the loop element? So someone sees these summaries and they rank them or complain about them or love them or something like that.
Yes, currently, so that's where this idea of like a gold standard comes in, a human generated summary or a human looking at a radiology report or MRI and saying that there's a particular disease or not in the scan is including the human in the loop. But in this case, having a human in the loop, since it's the medical field, things are always complicated. It's a system that is not entirely understood. It can create potential like errors or biases. So we're actually trying to find ways to create some gold standard labeling without necessarily having to have a human pour through the entire data set or trying to like minimize the amount the human has to do.
Is it a challenge getting the clinical summaries since we're talking about HIPAA
Yeah,
and
absolutely.
medical records?
I think I'm really fortunate to be at Stanford in a place where um, the research setting of that is able to make that happen and provide some like anonymized notes for researchers. But yes, that absolutely is a consideration. And we have like a secure working environment that we can't pull notes out of. A lot of the notes are treated as a black box and we can only look at trends or notes in mass.
And so, taking a step back, like the technology that this will provide is really going to automate the clinical side to some degree eventually. But what
Absolutely.
about the area of risk? Does it have any, in both good and bad, I mean, does it have ability to find things that the human would have missed? And does it also have the ability to make mistakes that humans would not have made?
Yes, absolutely. So that is definitely a really important question that we need to be considering. Right now, the systems we're designing are probably meant to be used in tandem with humans, not necessarily a replacement for any kinds of doctors. Specifically, the work we're doing in our lab is trying to diagnose cancers earlier than doctors could with traditional scans or tests. So those could be in the form of like a recommendation of, oh, maybe this patient needs to be screened a little bit extra, or maybe this patient needs to take a couple precautions and maybe get a mammogram or something.
And and for your research lab, you've just completed your first year at Stanford.
Yeah.
Has a conversation started about ethics? Is there curriculum around that? Because you're getting into a lot of realms that a traditional CS program wouldn't cover.
Yes, absolutely. And I think Stanford does a good job of including ethics in the classes we take, even in the medical school, I'd say it's even more so. But the conversation about ethics can never be started early enough. And I think anytime people are working with data of this sensitivity, it's really important that they have to go through some ethics training or recognize the effects of the data that they're using.
So from your perspective, someone who's newer to the field, and also with everything that's kind of going on with the world today, what's your personal fears or excitement about AI in general?
Yeah, absolutely. I think AI, specifically NLP, because that's the field that I have the most experience with, it has a huge potential to make a difference in our everyday life. Given the COVID situation, the number of novel applications that are just waiting to take advantage of NLP advances is continuously growing. So, for instance, there's so many papers being published about COVID. Summarizers could help us discover the most relevant parts in papers and put those in the eyes of scientists and the public faster. It could help people get information faster with more robust question answering systems. It could detect trends or patterns that we as humans have no idea about if this metadata is like accumulated. So I'm really excited by the possibility of AI to work in tandem to discover patterns or realizations that we as humans might not have the ability to do.
As other folks consider their direction in studying ML and AI, how did you come to form a passion for this problem space so early? Again, you only completed your first year at Stanford. Where did your journey start?
Yes, absolutely. So I've really enjoyed coding. I started coding in elementary school, and it was like simple drag and drop, scratch like things, and I really just loved it. And as I started going into high school and thinking about what I wanted to do as a career, medicine really drew me. But it wasn't the conventional, like medical school, being able to diagnose one person. It was leveraging tech to make huge healthcare impacts globally. And I think this marriage between healthcare and tech really just became the sweet spot that I fell in love with. I started doing a lot of research in that field in high school and have just been doing more work in that arena ever since.
There's such a division or silo, though. Of I I like to think of the medical professions as kind of the last professional apprenticeships, and it's really mired in craft. And you're talking about a population you're trying to help that aren't particularly computational. What are the challenges you've faced, and what do you anticipate in trying to proliferate kind of your ideas and your findings and trying to help human beings?
Absolutely. So, like you mentioned before, this idea of using data ethically and making sure not to overreach or use data that could potentially be that could potentially identify patients without an absolute need to is definitely a really hard thing to reconcile with a lot of the models we're building because the current age of machine learning and deep learning tends to be like the more data you can throw at a problem, the more compute power you can throw at a problem, you'll probably get better results. But in medicine, it's not that simple. You really can't put more data than absolutely necessary into these models. So trying to find that balance between, okay, if we provide the model more data, it will produce better results, but at the same time, we might be using more patient information and thinking about the trade-offs between the two. I absolutely see that as a line that we have to constantly consider as we're able to develop larger and better models.
Now, the that's an interesting point, and I've always been a preacher of that idea that eventually in all machine learning models, it's not about the quantity of the data; it's more about the quality and having signal, and then you eventually start adding noise to that. Um, but it sounds like also your problem is very layered. You talked about summarizations, you talked about images, maybe on a separate team, but still. Uh, and as some of our guests have mentioned, like Peter Wong said, it's becoming like quicksand sometimes if built too quickly. Um, what are
Mm-hmm.
your thoughts about that? The how stable AI solutions are, both from the engineering perspective and just the orchestration perspective.
Yeah, absolutely. I think that a lot of times people turn to AI or deep learning models as the first thing without considering simpler models that could maybe achieve the same results. And this idea that throw as much compute as we possibly can at a problem is flawed in the sense that there are better, simpler models out there, and ignoring them and turning to the most complex or the most state of the art for problems that really don't need models of that scale or size will create issues in this field.
What are your thoughts about that, Don? The moving too quickly, and I think of that. I point to you, Don, because of your involvement for a very long time with the startup scene. Not to mention Stanford's, contribution to many successful startups. But I always wonder, all these startups latching on AI versus these big players, the Facebooks and Googles and so on. What's the right approach? When is it to take it too far?
Well, yeah, I mean, Stanford's birthplace famously for Google,
Mm-hmm.
right? Possibly one of the most dominant powers of AI today. But just listening to Divya, I started pondering just Apple has lagged behind its competitors in AI. And part of that reason is how it treats data. But Divya, I just wonder if they're going to have an advantage when it gets to about medical use cases because they're working under constraints. And going back to startups, you've worked at two medtech startups, and we got to get to that since we have you on and you're a Stanford student, and we've got to cover that. But for startups, oftentimes constraints are good.
Yeah.
So maybe Apple will have the answer in terms of approaching the problems of medicine and health.
Yeah,
I
absolutely.
don't know.
And I think Apple might actually be in an interesting place because most people have like an Apple Watch compared to wearables by their competitors. And all that data that they're constantly accumulating about how much we're walking, when we're standing, what our movement patterns are like, what our resting heart rate, that could all be fed into some really interesting models and make some interesting advances in related to health.
Google had to buy Fitbit to get that kind of data, and
Yeah,
it was not
Yeah,
cheap.
right,
recent acquisition.
right.
Do you wear wearables, Divya?
Yes, I have an Apple Watch.
Interesting. And when I think about these this world of connectivity right now and IoT, and with safety around COVID and all of these things, there seems to be a lot more opportunity to apply it. But then I always hear people, well, I don't wear my watch because it runs out of batteries, and or I hear some really practical problems with the technology. What's your advice to people who want to start using technology for their health and using technology for the good? How do they make the leap from, like my generation, we were using the flip phones, and now even to get to the smartphones, it was a challenge for some. What's your advice for people who want to adapt new technology into their lifestyle?
Yeah, absolutely. So I think the biggest reason why people would jump from something like a flip phone to a smartphone is when they recognize the benefits and the utility that a smartphone brings them. And I think with health, it's very clear that health should be one of our top priorities. And when interesting advances are made in there that have the potential to help us live longer, happier, better lives, people will jump on it even if the technology isn't 100% there or perfect.
However, for access, the tough thing is an Apple Watch isn't cheap, and the populations, at least here in the United States, who most need help with their health are folks who can't afford an Apple Watch.
Right.
That's a good
So I think
point.
that does leave a large spot for innovation for cheaper wearables that could provide the same type of benefit.
Should
Probably
the
a good
healthcare
transition.
providers?
Yep, go ahead, Brian.
No, I was just going to say, should the healthcare providers and wellness providers be providing these devices? Should this be a right for all?
Yeah, that is an interesting consideration. I also strongly believe in the right that our data should be ours to own. So it turns into this kind of ownership debate in if an external company or provider is providing us with these devices, does the data like stay our own, or is it able to be sent to these providers? And that's a really interesting line that needs to be thought of before some kind of policy like this is implemented.
That's a good point.
And before we conclude the episode, why don't you share about your startup experience, and then we can conclude with your call out. I mean, we want to make Facebook a little anxious about whether or not you return again as an intern too. So we have to market you for your next internship.
Yeah, so I worked at two medtech startups, one in a more software capacity and the other in a more data science capacity. So one aimed to use hardware and software to automate pathology reports, and the other is trying to expedite clinical trial timelines. I really loved my experiences with both these startups. I think when you work at a larger company like Facebook, you get used to the internal toolings and the frameworks, and it becomes easier to just push more code more often. But the scrappiness at a startup where you have to build everything or find things online and integrate them into the project you're doing, read so much documentation, you learn so much on the job that I really don't think you can find anywhere else, because you have to take ownership of a piece of code or a product you build completely end to end. And that is an absolutely remarkable experience.
So you've been slinging some Docker and Kubernetes in there at the startups.
Yep, absolutely.
Very good. Hey, it was great having you on the show. Any way that you want to leave behind how to get in contact you from guests? Are you on LinkedIn or where do they find you when they want to offer you a great job?
Yeah, thank you. So I think LinkedIn or email would be great. Thank you so much for having me on this show, and it's been a pleasure.
Wonderful having you.
Sounds great.
Thank you.
Yep.